Okay, so hello everyone. This is our third programming meeting for counting from zero, and we're going to be talking about our final Java Basics class. So we're just going to wrap everything up in a nice, neat little class and make sure that everything works out. And so from here, if we have time, we'll get into the robot programming. If we don't, we won't. I did preempt the people on the Discord to download their VS Code and other dependencies from the Wapilot website. If you do not have that downloaded, please download that because it is kind of how we're going to program the robot, virtual robot, at least for now, but in real life, it's our actual robot. So please make sure you got that downloaded and set up. If you have any issues, feel free to message me on Discord or put it in the YouTube comments if you're watching on YouTube and are not on the Discord for a very strange reason. Without further ado, let's get right into it. So I'm going to share my screen. Should I share a tab or my window? I'll just share a tab. And we're going to put FRC training. Yes, that's the rebel. Okay, so let's get right into it. If you guys remember, last time we made our FRC.point value, and I had you guys make distance calculators. The amount of people who have submitted is very disappointing, but that's okay. It's a thought that counts, I guess. Beyond that, it's pretty cool. Thank you for at least submitting. Today we're going to do one more assessment, so make sure you do submit this one. It's going to be relatively important, and we're going to go over extending classes, base classes, and a few other things. So I did have a presentation planned out, but it's absolutely useless, so I'm just going to, I guess, essentially wing it. Not really winging it, though. There's a lot more content involved. So yeah, we're going to learn about base classes and extended classes, or I guess super and subclasses as they're known in Java. And so to give you a very basic example of it, we're going to be creating, let's say we're going to be creating a, vending machines software, right? So you guys have seen vending machines before, right? Have you seen vending machines before? Please tell me you've seen a vending machine before.
What's a vending machine?
If you haven't seen, I don't know, man. It's this very fancy magical portal to another dimension, right? And so you enter in a code, and it'll give you the address to this dimension. And so within this dimension, it outputs food items such as consumables. And these are not consumables that would have to be cooked immediately. They're actually pre-generated. So that's why these dimensions can preserve the food forever. Those things that kill 3 times as many humans as sharks. 3. Oops. I don't know. Many people have probably gotten stuck in these portals, but it's very unique. Anyways, jokes aside, I'm assuming you guys have worked with vending machines before, so I will continue along with that assumption. So we made our point last time, which is cool, math. I don't like math anymore because I actually have to deal with it, so let's just delete it. So to delete it, you can right-click it, or you can just click 3 dots over here and just click delete. It takes more than a second for some reason. Yes, delete this file. So I'm going to delete point.java because we don't need points anymore. It's pointless. That was the most pathetic laugh I've ever had, but that was a hilarious joke. It's pointless. Are you laughing with me? I'm laughing. Are you laughing? I'm laughing. Okay, so every item in the vending machine, right? So every single, let's say the milk bottle, the Nestea bottle, and those Powerade drinks nobody buys, like everything is somewhat categorized, right? Everything has a code within the machine. And we use this code to access the items, right? So this code is typically, let's say, I think it's 1 letter and 1 number or something, or it might be longer than that. But the point is, every item has to have some basic things. Like it needs to do something basic. And so the first basic thing it needs to do is it needs to be able to essentially, it needs to be able to like stay within the machine parameters, so be within the size. And then once you call a code, the machine should be able to push it out using either the spring mechanism or a crane or whatever mechanism the vending machine uses. So it should be categorized within the machine. The machine should have a count of how many items are inside of there, right? So if I have, let's say I have enough space for 5 Nestea, and all 5 are sold out, and someone enters in the number for a Nestea because they want to get one. And let's say that this is a very unintelligent machine, then what it'll do is, yeah, you want Nestea? Well, we got those. I mean, you can't see them, but we got them, bro. And so you put in your money, you press the combination, and no Nestea pops up because you're an idiot. Why would you even do that? But the point is, the machine doesn't have a way to find out. So the machine needs to keep track of how many Nestea bottles are in there, and needs to keep track of of the category or the combination or the code that you can use to access these items, and needs to keep track of some other information in case it's a more advanced vending machine. So each item in the vending machine needs to have some base capabilities, and we can actually categorize this. So instead of making, let's say for each one, let's say we're doing it in Java. For each one, a Powerade bottle and a Nestea bottle, we're going to write up the code, and we're going to write the same code multiple times, right? So we're going to write, oh, when this category is entered in, we want to take out this bottle. And so when we're taking out this bottle, we're going to write all the code for a bottle, which is bottle.reduceCount, bottle.getInformation, bottle.blah, blah, blah. So we're going to get all this information. We're going to write it out individually for each class. That sounds very dumb. Nobody wants to do that. So we want to make sure that there's a base class called a vending machine item, which can just take all the information that we want or all the functionality that we want for an item within the vending machine and keep it within that class. But different items might need different things, right? So you might have a heated section in your vending machine, and so you need to know if an item needs to be heated, right? So certain vending machines, not in Canada at least, but other places, they have heating capabilities, right? So you need to know which ones need to stay in the cold section, which one needs to stay in the hot section. Some of them actually serve food, like noodles that are made within the machine, or coffee, and so you need to say, oh, here are some condiments that can come with it, or here how to enter them, right? So there's some information added on to the vending machine, but there's some base information from the start. And we're going to be using this vending machine example to get our code essentially running. So let's get started. We're going to make a base class, right? And so a base class, remember, this is just the base functionality of each item in the vending machine. Each item should be able to do this. And we're doing this so we don't have to write the code again and again. And I'll show you guys how important that is. But do you understand the general premise of it at this point? Yes. Okay, we've gotten one yes. Yee. Okay, we've gotten a yee. Do you watch German children's TV shows? I do. It's funny because it's from a German children's TV show. Okay, moving on. Okay, so I'm going to take that as good enough. We're going to make our base class, and we're also going to have to make a new package. So let's plan it up. We're going to call this item, right? Because this is just a base item within our vending machine. And we're also going to need a package name. So REPL is being very slow, so is my computer. I'll just let that load up. And so we'll make a package. It's insensitive for me to have that in the recording. I might just have to use this voice recording. Okay, so package, and we're going to call this vending. Right, so vending as in just vending machine, pretty simple. And now we're going to make our class. So we want to make it a public class, right? Because you want everything to be able to access the item. The item should be something that everything should be able to access. And so we're going to make public class, and we're going to go to name. We're going to call it item. Remember, the name has to match the file name. Very important. A lot of people forget that. Do we need a refresher from last time? I think we'll get the refreshing done. Okay, so each item needs to have some base information, right? So the first thing we need to know is the name of the item, right? Like what's the name of the item? Is it Nestea? Is it Powerade? Is it Coca-Cola? Is it some off-brand Fanta? Because they're like C plus, there are 50,000 different types of orange sodas, but we need to know the name of the or the name of the drink or the name of the item, right? So, you can also have like chips within vending machines. So is it Fritos? Is it Lay's? Is it Ruffles? Is it all dressed Ruffles, right? So we need to know all these different things. And so we're going to need a name, and we're going to call this our string name. And so I remember in the chat, you guys were bringing up, oh, why don't we just make the string name public? And the reason we're not making it public is to sort of intersect that traffic, right? And so what I mean by the traffic is when Java tries to access an item, it will load up a version of the class through its heap stack, and it'll sort of run into it, and it'll be like, oh, look, I need this certain public item for it, and everything will be loaded up in this huge array of memory, right? And so the more things you make public, the more memory it uses. And so to save memory, we use these utilization functions, because functions don't use as much memory as just freely accessing a variable, because freely accessing a variable is so much more expensive, right? Like a string can do so much more than just one function that can access a string. And so for that reason, we typically don't make items public within a function, and we're going to maintain that practice. So just keep that in mind. So we're going to keep a string name. So this is going to be the name of whatever our item is, right? And we also have another string that's important. And so what string do you think this could be? It's something that we use to sort of get it from the vending machine. What information do we provide to the vending machine to get an item out of it? So Like I mentioned it before, it's the code. Oh my God, thank you guys for answering. It's the code. We enter in the code to the vending machine, and this gives us an item from it, right? So we're going to get our string code, right? And so this is going to be the code of whatever our item is. And beyond the strings, we also have some other number-based information, right? So what is one number that I mentioned was important if I don't want to get scammed at the vending machine? What's something that's important for the machine to keep track of, or at least a good vending machine? Yeah, how many items it has left, and money is also an important one. Yeah, so we want to keep a count of how many items it has left. So we'll call this count, int count, pretty simple. And we'll keep a double, and we'll call this price. Now, why am I setting this as a double? Why would the price be a double? Why would it not be an integer? Just a little bit of review from last time. I guess the first time, maybe. Because yeah, you have fractions of dollars. Not everything costs $2. Something could cost $1.50. Something could cost $1.25. Something could cost $1.34 for some very strange reason. You know, there are a multitude of prices. But the point is, you have different things. What else do you think is important for an item, or what else do you think an item should keep information of? Well, actually, I think I'll add it in because I don't think I'll get a lot of ideas. It could be a float, but we're keeping it as a double to maintain our precision, right? So we always want to make sure that there's precision within our code, and that's why we're keeping it as a who's what you call price as a double, not a float. Okay, so let me add in some more information, and let's get into learning about our next main topic as well. So one other thing that we want to keep track of instead of price is going to be our calories, because most people look at calories and good vending machines actually provide caloric information, right? So people are like, oh, how many calories does this Coke have? And it's like 500 because it's not very healthy for you. And they're like, oh my God, no, I'll take all the chemicals in Diet Coke, please. Right? So calories is something that people keep track of. So we're going to keep, so I'm just going to section this off using comments. I don't think I've mentioned comments yet, but I have used them. Comments are essentially lines of code that the computer doesn't read, but humans read. So your computer, if you put 2 slashes anywhere, right? So let's say I'm writing like 3 plus, and then I put like 2 slashes for some reason. It'll actually ignore the rest of the line because anytime I add 2 slashes, it just ignores it. The computer will ignore it, and the code will mess up. But the point is, I'm gonna use these comments to sort of describe it, right? So I'm gonna call these string values, so the name in the code, or maybe identification values. Maybe just identification. Maybe that's the smartest idea here. As you can tell, I'm winging this. Identification. There we go. I can spell. And then we'll call this our price, right? So all price. So all the thing important to price. And then we'll add one more section, and we'll make sure that this is for our not natural nutrition. We go. So you got calories, and what other thing is important, right? So let's say I'm on a diet and I can't eat a certain type of food. What would I look for in the item to make sure that there is something like not to make sure that there's something, but to make sure that I'm not consuming this item I can't eat, or maybe I have allergies. What am I looking for? There's something I'm looking for on the item. Can't really find it in a vending machine without Googling it, but smart vending machines will actually give you this information. Ingredients. Yes, ingredients. They're very important. I won't make fun of your spelling because I also messed it up. But, okay, so we'll actually need some more nutrition information, and that's going to be the ingredients within the food. Now, ingredients are multiple values, right? So if I just say string, and then I do ingredient 1, equals or something, right? So string ingredient 1, ingredient 2, and so on and so forth. That's not going to be a very good idea, because now what I'm dealing with is what if I have water, which has only 1 ingredient, and what if I have like chips, which have like a lot more than 1 ingredient? How do I dynamically, or how do I store these multiple items? And that brings me into our next concept, arrays. Arrays are basically a way to store a multitude of something within 1 variable, right? So it's sort of like a list. So you can imagine I have 1 shopping list. Well, yeah, you have 1 shopping list, but within the shopping list, you have multiple items, right? So in code, you refer to the list in one way. So you just give it a name. Let's say I call this the shopping list. And so within the shopping list, I can call each item within the shopping list, but I have to say that this is a shopping list at the top, right? And so in that way, we can make arrays in Java, or lists in Java. No, lists are different. We can make arrays in Java. And so to make an array, the syntax is very simple. Remember, syntax is how we type it out. So it's going to be string, and then you add these two brackets over here, or you could just, there are multiple ways to do it, but string, add these two brackets over here. And so these two brackets are basically signifying that this is going to be a list or a multitude of elements. And we're going to call these our ingredients. I made fun of your spelling, so I guess it's karma. So we're going to make an array of elements, and we're going to call this our ingredients. Now, keep in mind there are multiple ways to do this, as I mentioned. So I can actually have just a string, and then I can do this. String ingredients, and I can add the end quotes over here, right? And so there are multiple ways to do it, but I just prefer the two brackets at the start of the string. It just makes it a more concrete definition. Again, you can do whatever way suits you better. Okay, great. So now we have all of these different things that we need to know about our items. So now that we've sort of given the base, so what the item is composed of, we need to actually formulate our item. And remember, when we need to formulate an item or create an item, we have to define a formula, and this is called our constructor, right? So I hope you guys remember that from last time. We used a constructor on our point. And so we're going to make a public constructor because we want these items to be created everywhere. And so we're going to create a public constructor called public item. And then remember, when we put in the brackets over here, these are going to be the parameters. So what information do we need to give to this constructor so that it can formulate an item? And so the information that we want to give, there's quite a bit of it. We want to give the name of the item, right? So we're going to call this our string name. Actually, maybe we can just define this in a different way. It's effort though, and I don't know if I want to do effort. Okay, sure, whatever, that's fine. So we're going to do string name, we're going to do string code, and we're going to do int count, so how many remain, right? And so all these different values, and we're going to assign them if we want to do it that way. We don't necessarily have to do it this way. In fact, we don't even have to make a constructor of the item kind at all. And I'll show you guys what I mean by that. So I think we're just going to rid the item constructor for now because we don't really want to construct them at this exact moment. Now, what we want to do is we wanted to add a little bit of functionality so that the user can sort of, or that our code can do these things with our items without us having to type it out again. And so one thing that's pretty important, especially when we are getting our item set, is going to be like our count. So like we're going to make a public, and we're going to say how many. So how many of this item are remaining, right? And so we're going to make this a public function, and we're going to have to define the return type as well. And so we're going to be returning an int or an integer. And so returning an int basically means that we're going to return a value of the type int, right? And so we just want to return our count. I'm going to return count over here. Simple. Okay, great. So now we get how many are left, but now we also want to know, we also want to buy items, right? So we're going to say public void, right? Void means there's no return type. We're not returning anything. And now we want to remove an item or buy an item. And so when we buy an item, we're going to just remove one of the items from it. Or not like that. We're just going to do count minus equals 1. And hopefully an error pops up. I don't know if it will actually. Oh, it doesn't. No. I don't know if it works either. Because it might have to be static. Ugh, okay, well, whatever. Did I teach you guys static last time? Do you guys know what that means? Static and final? Did I explain that? I don't know if I did. I don't think you did. Yeah, I don't know if I did. I can very quickly go over it if it arises, if the issue arises. Okay, so public void buy item, right? So when we buy an item, we want to take 1 away from the count, but everything else is good. But we also want to make this instead of a void. We want to tell them if there are no more items left, we want them to know, oh, you can't actually buy this item, right? So we're going to return a Boolean. We return true if their transaction is valid, or we return false if their transaction isn't valid, right? And so the way we're going to do this is, or maybe I return an int as in the cost that they need to spend. That's a good idea. So instead of returning a Boolean, okay, I'm changing the idea, we're going to return an integer. And so what this integer is going to do is it's going to give them back the cost, right? So how much do you need to pay? So let's say I buy item E3, and E3 is a nice old bottle of water which costs $1. Then this function will return $1. I should change this to a double then. And then let's say I'm buying an Nestea, and that costs about $2.29 for some reason. Then this function will return a $2.29. Now let's say that I wanted to buy chocolate milk, but the chocolate milk is $1.89, and there are no more chocolate milks left. Then what that's going to do is it's going to return a -1. And when it returns a -1, we know that there is no more chocolate milk left, right? Because you can't pay $- for anything. So we're going to say that when something is -1, that means that there is going to be no item there, right? So we want to add that sort of escape case. And so the way we're going to do it is public double by item. And we're going to check. So we're going to learn about if statements. Did I teach you guys if statements last time? I think I did, right? Did I? I don't think so. Okay, well, no. I got to teach you if statements, basic logic. Fun. So if statements are pretty simple. They work something like functions, just a little bit different, right? So remember, not remember, but what we're going to do is if we can imagine it as a function. So if, and then in the brackets, we need to provide the parameters. And this parameter can only be a Boolean. So you can only put a Boolean value in here. Now, what that means is if I have, let's say, a Boolean value, and we call this game over, and we say that this is equal to true. And what this means is the parameter that I can provide here is it can just be game over, and that's perfectly fine. But I can also provide other Boolean values, and that's going to be sort of these are comparisons, right? So we're going to say if game over is less than or equal, not game over, if count. If our count, so our count of how many items we have left, if our count is less than or equal to 0, then we're going to give it some instructions, right? So remember, when we give instructions in functions, we put these curly braces. What do you think we'd use for if statements over here? What do you think we can do to give instructions if a certain thing is true? These curly braces for functions. More curly braces, you get a prize, which is, I guess, my respect. Okay, now, we use these curly braces, and now, if we know that count is less than or equal to 0, that means we can't buy the item. So once you know that, we're going to say return, right? Because we want to return something, and we're going to return -1, right? So you can't pay $- for any product. In that sense, we're going to say -1. And so the computer will know -1, oh, that means that they can't buy it, just because we can't pay $- for anything. Now, if this is a different use case, and it's like plotting points on a grid, you can actually have number -1 on a grid. So you'll need to find a different value. You can return -infinity if you want to. But I'm just going to return -1. And the reason I'm doing that is because we know that it'll never come again, right? And so next to if, we can actually add a few more instructions after that based on the wording. And another one is going to be else if. And so what else, or no, the second keyword here is else, right? And so else is basically going to be, if the first statement isn't true, then I'm going to be doing something else. Hold up, I think I'm getting a call. Give me 1 second. Okay, call has been dealt with, but apparently not on my laptop. Thank you. Okay, so else is basically going to be if this statement, right? So if count is actually greater than 0, so it's either 1, 2, 3, so on and so forth, then we're going to run into our else statement, right? And so from else, you can do whatever you want. So after else, I can actually just provide more instructions like this, and this is just going to say, like, it's one or the other, or I can use another if function again. So this is going to be called our else if. Some people get it really confused. They think else if is its own individual operator. It's actually not. It's just a combination of else next to if. And so to prove that, what you can do is you can actually do else on one line. So let's say that the cost for everything is always going to be 1. Then we can actually just do else return 1 over here, and it's not going to give an error because you don't need curly brackets if your instructions don't extend to multiple lines. So what that means here is you technically don't need these curly braces, and this code is still perfectly valid, which is confusing. So most people like to keep curly braces in their code. But the point is, else if is not its own individual operator. It's actually separate. Oh, I used two curly braces. Oh, closing here. Else if is not is not its own individual operator. It's actually just a keyword, right? So you can do anything you want after else. So I can do else, and then I can make another if statement, right? So it'll sort of turn into a branch. So it'll do, if this is true, then do this. If not, then do else. And then from else, if this is true, do it. If not, then else. And then from that, and so on and so forth. Do you guys understand the else if sort of structure and what else if means? If else, else if. Yep. Okay. Perhaps. Mayhaps. What are you unclear about? I can try to clear it up if it's a little confusing. You know, technically, we can do all of Java in like one line. When people said Python was good, pathetic. Okay, let's continue. Enough Python hate. There's no Python hate. There's no Python hate. Okay, so else. So if we know that there is count, right? What do we want to do? We want the machine to take away one of the count items. We want to vend the bottle, right? So we wanted to say, oh look, there's one less bottle or there's one less item. We wanted to vend the item, right? So we can't do that in the code. So we're just going to ignore that. And then we want them to pay whatever the amount is. So we'll return the price. And so let's do the first step of that. Where we'll do count minus equals 1. And so what this means is, or actually I think we made a function for that. No, we didn't. Okay, so what we're going to do here is we're going to take 1 away from the count. And so what this is saying is I've bought 1 item, that means there's 1 less. So if I had 4 at the start, I bought 1, that means there's 3 left. And that's essentially all it's saying. And now we're going to return the price of our item, right? So we know that the price is already predefined, so we can just say return price, and we're good to go. There we go. Public double buy item function is complete. So we can now buy items with our vending machine code, I guess, to an extent. Next, once you know that, we want to, what else do we want to be able to do? I think name code we do somewhere else. Name isn't really relevant right now. Maybe we just want to do the 2 strings so that we can print it out. And, oh, nutrition, so calories. Okay, yes. So we also want to return how many calories are in our food. So we're going to make a function, and we're going to call this public how many cal, because I'm not fully typing out calories for the life of me. And we want to set a return type for this, right? Because it's not our constructor, we need a return type. And so to set the return type, we know that calories is an integer. So we're just going to do public int how many cal, and we will return calories. There we go. Finally, we will have 1 more, and we're going to learn about another key programming concept. And this is the concept of a loop. And so you guys are in for a treat. Now we're going to do public, and we're going to return a Boolean, right? And so this is going to be a function for has ingredient. Right, so let's say our vending machine is a nice, intelligent one that people paid money for. We're going to say, oh, look, you can press a button and you can speak in a word, right? So let's say you speak in peanuts because you're allergic to peanuts. You can say, does this item have peanuts? And the computer will be like, no English. What are you saying? No, I'm joking. It'll be like peanuts. I will analyze the ingredients. And if it doesn't find any peanuts within the ingredients, it'll say, nope, it doesn't. You're good to go. So it'll return a true, or else it'll return a false, right? So there are no peanuts in the food. And then if there are peanuts in the food, then I'll say true. Yeah, there are peanuts in this food. Does that concern you? And you'll be like, yeah, I will die if I eat it. And be like, yeah, good job. The people bought this. And everyone will be happy. And life continues on good and well. So we're going to make a public Boolean, and we're going to call this our has ingredient. And so what information does the machine need to know to process this? What does it need to know to process has ingredient? The ingredient is looking for. Yeah. And so since we specify that ingredients are strings over here, we're just going to say public Boolean string ingredient. I added the space there. So we're going to give string ingredient. That's going to be our information that we provided. And now we want to check all of our ingredients and make sure that we have the right one. And here we get into our 2 different types of for loops. Yay. So for loops work sort of like English if you use the easier kind. And this is going to be our for each loop. So that's the first one I'll teach you. So we're going to say for, and now we need to provide what we will iterate through. So what is going to iterate through. And what this means is what is going to run through each single item of the list. We're going to say we want a string and we're going to call this item ingredient, right? So we're going to say string item ingredient, and this is going to be each single element in the list, right? So if I have, let's say, a list of 10 different ingredients, or 3 different ingredients, or let's say that this is some very basic juice. I have natural fruit flavors, water, and sugar, right? Those are my 3 ingredients. Then I'm going to say each of these ingredients will be item ingredient at some point, right? So we start off at natural fruit flavors, we move to water, and then finally we touch sugar. But each of these we will call item ingredient, and we will iterate, or we will run through each of the entries within our list, right? So you're going to say, what item am I going to buy next on my shopping list? Well, each of the items on your shopping list is an item, right? And the current one you're pointing to is going to be your selected item. In that sense, this is going to be our item ingredient. So we're going to say, for each item ingredient of type string within, or so this colon specifies within, so what we're looking at, and that's going to be our ingredients list, right? So we're going to say, for each item ingredient in our ingredients list. That's all this stands for. So for each item ingredient in our ingredients. In very basic English. And it's pretty easy to understand because it's similar to other language. So for each item ingredient in ingredients. Does that make sense to you guys? So you put so for each, so like what is the each, and then what is it you're looking through next on the other side of the colon, right? So for is like a function, and you're going to put in, these are the parameters, right? So for each item ingredient in ingredients, and you're going to close that off with the instructions that you'll do for each item ingredient in ingredients. Does that make sense? If it doesn't, I can try to explain it again. Couldn't you say, yeah, the reason I said item ingredient is because I use ingredient as the name of the parameter over here. So that's just a little complication there. Yeah. I mean, I could rename this one to looking for, or ingredient to look for, but that's just such a long name. So item ingredient is easier. Okay, anyways, what we're going to do is now we're going to, actually, sure, you know what, I'll do that. Item to look for. You know what? Fine. You've played my hand. So for each ingredient in our ingredients list, right? Or array. I would say array. I say list, but they're very different. List is dynamic, right? So if you imagine a shopping list, I can actually add more items, or I can erase items off of my shopping list. And array is more like, I have this much space, right? So I only have these many lines to write whatever I want to, and that's it. I can't add more. I can only erase them, right? So I can erase current ones, but I can't add any more. And that's kind of the difference between an array and a list. I'll get more into it, but don't worry. Anyway, so now what we're going to do is, if our ingredient is the ingredient to look for, then we want to return true. If it's not, we will return false, right? And so the way we can do that is we can use another if statement, right? So if our ingredient to look for, and so it's a common mistake. And I've seen like pretty experienced Java programmers do this sometimes when they move to other languages. So in Python, if you have experience with that, or other languages, you do equals, right? So equal is going to be our is equal to operator. So if ingredient to look for equals, or if it's equal to the ingredient, then we want to return true, and so on and so forth. But this is very wrong, because in Java, you compare the dot equals for non-primitives using a special function called equals. And so what this is going to do is, it's because string is not a primitive, remember, primitive is like a Lego brick, and because it's like a machine, or because it's like a mechanism, you want to compare them in a different way. And the way Java differentiates this is using the dot equals function. So you're going to do if ingredient to look for dot equals, and this will return a Boolean. Remember, we want the if function to have a parameter of a Boolean. And so if this ingredient to look for dot equals ingredient, so if they're the same, then we want to return true over here, right? So has the ingredient. This comment provides nothing. And then let's say that this is going to look through every single ingredient in our ingredients list, right? So after it's looked through every single ingredient, if it doesn't find the one we're looking for, if none of them are equal, what does that mean? If none of the ingredients within our list are equal to the ingredient that we're looking for, what does that mean? The ingredient is not in the item. Wow, that was like, bro, I should call you Einstein from now on. Yeah, so now that we know that the ingredient is not in the item, we can return false. And that's going to be essentially all the processing we want to do within our item function. So this is going to be our base, and we're going to build everything else off of this. Okay, sound good? Sound good? I think that sounds good. So we're going to try to run this just so I can package it and it doesn't break apart. Give it a second. Okay, there we go. We're good. Now, we're going to make our different items. I only have about 20 minutes left, so I'm going to minimize it to about, let's just call one water, no, or maybe like Powerade. Powerade is ridiculously expensive, but it's in like every single vending machine for some reason. So I'm going to make a file. I'm going to call this Powerade.java. Now, what do you think? What do you think? Just like think about it very closely. What do you think would I set the class name to for Powerade.java? Oh, I actually didn't teach you the other loop method. Hold up, let's do that. No, let's do this. Powerade. The class name is Powerade. That was such a trick question. I know I got you guys with that one. Okay, so let's learn the other loop method. This is going to be more complicated, a lot more complicated, but that's okay, because complication is our name. So for this is not going to be the for each loop, and as such, it will be explained so much differently. So this for loop is actually going to be more of a syntactical for loop, and the way that's broken apart is each for loop has 3 different sections in the parameters. You don't separate these sections with a comma, you separate them with a semicolon. And so the first section is called the initialization phase. And this is going to be what happens at the start, right? So let's say you can imagine this sort of as like a, maybe like a match or something, right? Yeah, I think a good like basketball game or soccer match. Anyways, so the initialization, this is what you do at the start, right? So everyone enters the court, the coin is flipped, whatever happens at the start of the game, right? And this is the initialization. It only happens once, and it happens at the start. And so in our case, well, I'll explain what we do in our case. And then there's the second section of it, right? So remember, there are 3. The second section of it, this is what happens throughout the game, right? So throughout the game, someone scores on one side, someone scores on the other side, right? And so once a score is entered, something changes, right? So or something will have to be entered, or some other game-winning condition will have to be defined, but something will happen throughout the game, right? And once that something passes a limit, right? So let's say it's a timer, right? So in a soccer game, it's a timer. Let's say that the timer is reached. So you've played above, I think it's 90 minutes for a game. I don't even remember. You've played above whatever the limit is, right? Or you've scored a certain number of points, or you've done something. Once this win condition is defined, you move to the last phase, which is the end phase. And this is what happens once the game has been ended, right? So the obligatory awkward handshakes, the news reporters, the slow walk into the locker room, whatever you want to define. This is the end phase. So this is what you do only at the end. And you only do this at the end of each step of the match, right? So let's say, actually, no, I defined that so incorrectly. It's sort of like the match continues on, right? And let's say I score a point, right? Let's say we're playing soccer and I score a point. So I did the start of the game. I scored a point. What happens is it jumps to the end, right? It jumps to the end, and it's like, oh, okay, now we do the sort of slide and the happiness and the cheers, and then it jumps back into the match, right? And this continues until the match somehow breaks. So the match-winning condition is only within the end. Let me explain what this means in programming terms, because that's what I'm good at. I'm not good at soccer games. That's why it was a horrible analogy. You can thank me for that. So this is going to be our start. And at the start, we're going to define our index, right? So what an index means is our array is basically like a shopping list, right? Except you can't add more items to it. It's just a shopping list to an extent. What this means is you start at the first element, right? So we can call, because counting starts at 0 in programming, you have the first element, which we'll define as 0, 1, 2, 3, 4. That's how you count, right? So 0, 1, 2, 3, 4. So if I have 5 items in my shopping list, that's 0th item, first item, second item, third item, fourth item, right? So 0 is always the first way you count. And so we're going to call this index our pointer, right? So let's say we want to go from 0 to 5. Our index is going to go from 0 to 1 to 2 to 3 to 4, right? And so we're going to say our index, and we always start at 0. So our index will always equal 0. Remember, now that we added a semicolon, we're moving to our second section. So this is what will happen throughout. So after you finish whatever instructions you give the for, this will happen, and it's sort of that match winning sort of deciding factor. And what we're going to say is index is we need to check for something here, right? Because this is our match winning condition. Once something happens, we need to make sure that you haven't won the match or anything, right? So if our index, and we want to return false once we've done that. So if our index is less than, and we're going to say, what's our ingredients dot length? Okay, and so what this means is we're going to go, our index is 0, and then our index, if it's less than the length of the list, right? So if we haven't crossed 5 or more, right? So if we know that there are 5 items in our list and our index is at 4, that means our 4 is less than 5 because 5 is the length of the items in the list. But let's say it's at 3, that means it's also less, that's good. So right, 0, it's good, 1, it's good, 2, it's good, 3, it's good, 4, it's good, 5, it's not good anymore. And so once it hits 5, it's going to exit. The game-winning condition is done, the match is over, people leave, it's done. And then if it isn't done, so in the case that it isn't done, and it's a successful point, or it's a successful something, then we're going to continue, then we're going to do whatever's in our third section, and this is going to be our continuation. And here we increase index by 1. And you can do this in multiple ways, index plus equals 1, like this, or you can just do index plus plus, which is abbreviated as just increment by 1. Now, that must be very, 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 very confusing. Many varies. And that's kind of why I sort of stayed away from using it. But the way that you would do the rest of it is essentially you do if, and then you'd say ingredients, and then you point to the index, right? So oh my God, that was horrendous. Ingredients, right? And so you access an array of this shopping list, or you access an element of the shopping list based on where it is, right? So let's say I have 5 items. Oh, can you give me the third item on the shopping list? Well, the third item on the shopping list, I'm not a programmer. That's going to be 1, 2, 3. That's the third item. I give it to you, right? But in programming, of course, index counting starts at 0. So if I say give me the third item, you realistically give them the 4th item, right? But you just give them the item that's its a position, right? So the position of the item is what matters. So index is just the position that we're currently at. So index is either 0 to 4, and so we just give them something that's at that position. And so we just say ingredients.index.equals, not dot index, at index, dot equals, and then we just ingredient to look for. Again, much more complicated. I don't like explaining it. I could probably explain it in a much better way. I suggest looking at YouTube tutorials. They probably know soccer, so they can explain it without dying. For each loops, much simpler. For each string, for each ingredient in ingredients, much nicer. Sometimes you will be forced to use a for loop that's different, but for now we aren't, so life is good, and we will continue along that way. Okay, considering there's no comment, I'll assume most of you are lost. It's okay, let's get back to this. So we want to make sure that our power rate is also in our vending package, because we want everything to be related, everything related to our vending machine to be within that package. Next, we're going to make our public class, because again, we want our power rate to be accessed by our main class. We're going to say our power rate, and typically at this point, you would just add the curly braces and you'd add your instructions in the bottom. But we want this to take our information from our item class, and we just want to add more information to it. And so how do you guys propose we do that? I mean, you wouldn't know, but I know. So the way we do that is we want to extend our base class, right? So item is our base class, and we want to extend it. So we type extends, right? So extends like that, right next to the public class power rate, and we say it extends item. And now your compiler will freak out because it probably doesn't know where item is. And so to fix that, you just do import vending.item. Perfect. Now our power rate will extend, which means it'll extend all this information from our item. So everything from our item is now within our power rate. But how do we set it up so that it works properly? And the way we can do that is we can make actually the constructor within this power rate. And so what that means is we can just say we have the formula, but then you might be thinking, oh, but where did the name go? There's no string name here. Well, the string name is copied over from item when you extend it. You can imagine it sort of as like you have a base layer, you're just putting another layer on top of it, like another layer of paint on top of the old one. It's not like the old paint is gone, it's still there. It's just that there's a new layer on top. And in the same way, we're just extending an item. So we're keeping the old information there, and we're just putting more information on top. We're going to say public, and we're going to make our Powerade function over here. So public Powerade. And we want to know some information while we're making this. One thing we want to know is, how many do we have in our vending machine? That's important. What is the price of them? That's also important. And I guess something that would be relevant would be ingredients. Actually, no, we can define ingredients by ourselves. So I guess there's nothing really all to, what else was here? Calories, I think we can define that by ourselves, but what's really unique? What is dependent on the vending machine? The code. The code of the thing is also dependent on the vending machine, right? So the caloric information, if I get a Powerade from a vending machine in like some random country, not some random country, if I get it from like Barrie or I get it from Brampton, the Powerade details are still going to be the same. It's not like the ingredients change because I get it from a different region. It's just going to be some information like the code, the price, and the amount that are within the vending machine that change. And that's why I'm just making these the amounts or the things that are within the vending machine. Does that make sense? The whole vending machine dependent parameters, right? So it's like, the way you can imagine is, let's say I was getting Powerade from a vending machine after my game, and that was in Caledon, right? That means that if I get it from the machine there, the cost might be a little bit more because they don't get a lot of delivery trucks down there for some reason. So it might be $3 for a Powerade, and they might only have like 2 left because it was just after a game. Or they might only have 2 there because their vending machine is small and they don't have enough space to stock up on more. And the code is obviously going to be different, right? I might have to enter something like D2. And let's say I buy it from somewhere in Brampton, right? So let's say I get it from Earnscliffe or something. It's a complete ripoff. The price is like $5 for some other obscene amount because they mark it up for some reason. They have a lot of them though because nobody wants to buy overpriced ones. So they have like 6 of them. And the code is going to be something different as well. It's not going to be D2. It's going to be something like E5 or something, right? So the code and these things change dependent on the vending machine. You put code before the other parameters. Is there a reason? No, not a specific reason. I just sort of just did that for the ordering. I think it's, yeah, for alphabetical ordering. Code, count, price. There's no specific reason. Okay, let's continue. I think you guys understood. I hope you guys understood. Okay, so since we know that the name of the Powerade is going to be the same thing regardless, what we're going to do is we're going to say name equals Powerade, right? And so now your compiler might be freaking. I actually don't know if this caused an error. I think they updated it, actually. They might have updated it. They changed Java so much over the years. Oh, this actually works. Yeah, so you can say name equals Powerade, right? Because we know that the name of the item is going to be Powerade regardless. Next, we know that a few of the other informations that are relevant. Let me just open up item over here. We know that the count and the price are different. The calories we know are the same. I don't know what calories are in the Powerade, but I'm going to assume it's something like calories. No, calories. But I'm going to assume it's only like 300 calories, right? And then we know that the rest of the information is really dependent, and ingredients is the last thing we know. So let's learn how to make ingredients. It's equals, I think, does this syntax work in Java? It works in C. And so we know that Powerade has water. Water is a good ingredient. And we know it has salt, because they need some salt in there. We know it has sugar. And we know it has artificial flavor, right? So now that we have all this information, we can just keep it there. Now, the information that's dependent on the specifications of our vending machine, such as the code, the count, and the price, we can actually just assign those as we normally assign them, right? So I'll just add these with underscores to differentiate them with their current variable names. So we'll say code equals underscore code. So that's the code that we've inputted. Count equals underscore count. That's the name that we've inputted. and price equals underscore price. That's the name that we've inputted. Now, if I try to run this, it shouldn't break apart, I hope. I think I might have to, yeah, okay. Illegal start of expression. So I think I have to do new string this. Yeah, okay. So what I mean by new string over here, remember, string with these two brackets over here is how we define what type of, that it's an array, right? So we know that this is a string array. And so this is just going to be the information in the array. So the curly braces, remember, are like instructions. So these are just instructions that we're providing. And the instructions are just the different items that are within this array. And that's all I'm doing over here. Does that initialization make sense to you guys? I don't think we use a lot of arrays in robot programming, so you guys should be fine. Very quickly, I think that we're good over here. So we've made our Powerade, which extends our main item. And now we're going to import that over here. So we're going to import our vending.Powerade. Now we're going to make a new Powerade machine. And so we're going to say Powerade. And we're going to call this orange Powerade. Oh, that's actually something I wanted to add over here. So we made our base Powerade class, but the different colors of Powerade, and that's what differentiates them. So we can actually make more information. It's not like we can only use the information from our item class. We can actually add more information. And so the more information we can add is, let's say we make a string and we call this our color, right? So we can actually add our color information, and we can add in our color over here as well. So we add in our color information over here, and we say color equals underscore color. Color wrong here, right? And so what this will do is this will essentially allow us to differentiate the different sorts of Powerade that we have. So we can have a Powerade that has, like we can have a pink Powerade, we can have an orange Powerade, and so on and so forth. They all have different counts, but that's something different, right? So not all drinks have different colors. Nestea doesn't have colors, but Powerade does have different colors and different flavors. Depends on how you want to say it. And that's how we can sort of differentiate them, right? So some drinks might be heated. We know that Powerade is not heated, so we can make a Boolean in our main item class, and we can call this our heated items, right? So we can go over here, and we can try to make another one, and we'll say that this is vending dependent, and we'll call this Boolean heated, right? And so on and so forth. So what, since we're coming to our closing remarks here, and since I have blabbered on long enough, if you guys have any questions, feel free to ask them after I finish my next little spiel. Let me just stop the recording. Did I stop the recording? Was it something? Okay, you know, I'll just stop the recording over here. Okay, so your homework assignment, I will make it clear it's going to be on the Google Classroom, but I'll also upload my REPL.it. I want you guys to make sort of like a vending machine UI. Not a UI, just a command line sort of user interface, where it's just going to be like, oh, this is how I'm going to make, or this is how I enter the vending machine. It lists out the codes for me. I enter in a code, it gives me the item, and tells me how much I have to pay, right? And then I pay that amount in whatever way, you know, just virtually pay. And that's how it works. So I'll post the details on the announcement later on, but that's just going to be the general instructions. If you guys have any questions on that or on anything that I sort of went through here, just let me know. Again, if anything's confusing, then that's fine. But yeah, just try to make that work. I forgot to teach you while loops, but that's unfortunate.